Okay, so this is relativity length contraction problem number 3, and here's the equation. The question: an unstable particle is created in the upper atmosphere from a cosmic ray and travels straight down towards the surface of the Earth with a speed of 0.99860 c relative to the Earth. A scientist on the surface of the Earth measures that the particle was created at the altitude of 60 km. So for the first question, which is A, as measured by a scientist, how much time does it take for the particle to travel to the surface of the Earth? So the equation we have to use is d over v, which equals t. When we need to first we have to do 60 times 1,000, which gives us 60,000, and then you just plug it in for the next part of the equation, and just 60,000 over 0.99860 c. And when you divide that, you get 60,084.12, and that equals t. Now for B, use the length contraction formula to calculate the distance from when the particle is created to the surface of the Earth in the particle's frame. So how you do that is you just use the length contraction formula, which is L equals LO, and then square root of 1 minus V over C squared. So when we plug that in, it's 60 equals LO square root of 1 minus 0.99860 c over c. Put that in the calculator, and you should get 0.0014. Then you divide that by 60, and you should get 2.333 e to the negative 5. Lastly is C, and C's question is, in the particle's frame, how long does it take for it to travel from its origin to the space of the Earth? Calculate the time both by the time dilation formula and also from the distance calculated in part B, and it's a negative 4.